Chapter 8, Chemical Reactions. A chemical reaction is one or more substances being converted into one or more new substances. The reactants are the starting materials that we add to the cocktail, and the products are the newly created substances that we have in the end. We show this by using a chemical equation. This represents a chemical reaction. The reactants are on your left, and the products will be on the right. The arrow means react to give. So which of the following equations would represent chemical reactions? As you can see, water going from a liquid to a gas is not a chemical reaction. But carbon dioxide plus water going to H2CO3 is a chemical reaction. So is the third one here. Consider the following reaction. H2 plus I2 giving you 2HI. We have a colorless, highly flammable gas, which is not very soluble in water, turning into hydrogen iodide, which is a colorless, acrid gas, dissolving readily in water. Notice that the chemical and physical properties both changed. First, we have the gas phase reaction. This is where both reactants are gases. Particles move very quickly, and they're overall random directions. So at 425 degrees, molecules move at very, very high speeds. Then we have reactions between molecules. Molecules collide at great speeds, releasing energy to break the molecular bonds. Here's a chemical reaction taking place. We do need to make sure our chemical equations are balanced. This is a shorthand way of representing a reaction. The number of atoms must be the same on both sides of an equation. So here we have 2 hydrogens plus 2 iodines, creating 2HI, okay? If you see a 2 in front of a molecule, it means there's 2 hydrogens and 2 iodines. There's 2 of everything. So we balance equations by placing coefficients before reactants and products. If H2 plus I2 goes to HI, we need to make sure that if there's 2 hydrogens on the left, that we have 2 hydrogens on the right. So here we have H2 plus I2 goes to 2HI. So why isn't it 2H plus 2I, or 2H2 plus 2I2 goes to 4HI? Traditionally, chemists use the smallest whole numbers as coefficients. Never balance equations using subscripts. So for example, H2 plus I2 goes to H2I2. This is impossible. This hypothetical molecule is completely different from HI, which is the actual product. Changing the subscript changes the compound. How would you balance the following equation? Pause here and press play when you're ready to see the answer. In this case, we get 2 nitrogens and 2 hydrogens. We need to make sure that there are 2 nitrogens on the right, and in this case, since we have H2 on one side and H3 on the other, if we do 3H2, we've got 6 hydrogens on the left. And if we do 2 H3s, we have 6 hydrogens on the right. So that is a way that we could make it equal on both sides. Try balancing this equation. Press play when you're ready to see the answer. In this case, we had to put 2 oxygen molecules on the left and have 2 water molecules on the right to make sure we have the same amount of carbons, the same amount of hydrogens, and the same amount of oxygens on either side. Next, we're going to look at different types of reactions. I love these because they actually look like they're the terms that they're called. There's a single replacement reaction, double replacement, decomposition, combination, and combustion. You're going to have to be responsible for looking at an equation and trying to figure out which type it is. An example of a single replacement reaction is where one element replaces another. In this case, you can see we had 2 aluminum plus 2 Fe2O3. And in the reactant side, the oxygen jumped from the iron over to the aluminum. So that was one replacement. A double replacement is where 2 elements replace each other in 2 compounds. And here you can see the PCl3 plus 3 AgF. The chlorine hopped over to the silver, and the fluorine hopped over to the other side. So 2 things switch spots. In a decomposition reaction, this is a compound that breaks down. So here we got 2HGO being broken apart. So it's decomposing into 2 things. Combination is just the opposite. 2 things combine to make 1. Here's an example that shows it with colors so you can see the actual switching, or the decomposition, or the combining. Another type of reaction is called a combustion reaction. These are reactions that involve oxygen, and we call this burning. It can fit into other classes as well. In this case, we've got methane plus oxygen going to CO2 plus water. Try to balance and classify this equation. Press pause here and push play when you're ready to see the answer. In this case, it's a single replacement reaction because potassium bromide replaces bromine with chlorine. You can see we had to do 2 potassium bromides and have 2 potassium chlorides in order to balance the equation. So we have the same number of potassium, same number of bromides, and same number of chlorines on either side. Then we have a precipitation reaction. This is where we get a solid to form. In your first 2 labs in the Introduction to Chemistry laboratory sections, you became familiar with that precipitate. You added a liquid, in this case it's being called aqueous with AQ, to another liquid, and you saw a solid form in there. That's an example of a precipitation reaction. Aqueous plus aqueous going to a solid. Then we can have dissociation. This is the separation of an extended lattice. Ionic lattices form ions, and covalent lattices form discrete molecules. Here we're seeing simple table salt. NaCl, aqueous, denotes that we have sodium ions and chlorine ions as an aqueous solution. So when you add salt to salt water, or to water, it turns into a salt water. The salt doesn't just sink to the bottom, it dissociates. We're just going to have a brief introduction here to acid-base reactions. An example of a common acid is citric acid. When added to water, it dissociates, producing up to 3 hydrogens. An acid, and here's a definition you need to be really familiar with, guys, is any compound that dissociates to produce hydrogen in water. Examples include acetic acid, hydrochloric acid. A base is a substance that dissociates to produce hydroxide in water. Examples include sodium hydroxide, potassium hydroxide, calcium hydroxide. We can also acid-base neutralize. If we add an acid and a base together, it can neutralize each other. An example is a net ionic equation as seen below. Hydrogen ions plus hydroxide ions make water.